And we're live from Ms. Holcombe.
Functions and graphs. So this is 1-2. This should start to ring a bell from Algebra 2. We are looking at functions and graphs. This lays out everything that we're going to do. By the way, if you ever see applied problems, that means word problems. This tells you where we're going. We will not make it through this entire packet today. I would never try to make it through something this dense in one day. So we will just get started on it. The whole thing's about to crash in 3, 2, 1. Yeah. Hold on. Let's try this again. 1, 2. Okay. Let's refresh your memory on what a function means. We're going to start very basic. There's nothing to write on this slide. This is just you looking at the different ways to present an applied problem. For instance, a pay-as-you-go exercise program where you pay a flat rate up front and then you pay for every visit. That's how you interpret this equation right here. So it's $20 is your membership fee, and then it's $7.50 every time you attend a class. So because of this equation, you can set up a table of values. If you attend one class, you will have paid $27.50. If you attend 2 classes, you will have paid $35, and so on, which generates ordered pairs, which can be presented on a dot plot to show you the more classes you attend, the more money it costs, right? Now y'all can go. I got 5. There's like 5 in there? Are you wanting cookies, Lucas? Lucas? They might be out. You better hurry. I'm being for real. This is a dot plot to show the relationship between the number of classes attended, the number of the cost that you're paying. What makes it a function is because if you spit out any single number, 10, 11, 15, 22, if you say any number of potential classes you would attend, you can type it into this equation and you will get one exact answer of how much money it's going to cost you to attend, say, 20 classes. That's what makes it a function. Let's refresh your memory on the relationship in functions, the domain, the range, the correspondence. Here are 3 real-world examples of functions. Every single person in the world is assigned a DNA, right? Has a DNA. So that is a function because there's no 2 DNAs alike. Does that make sense? So any 2 people you pick in the world, they have different DNAs. That's a function. Each truck sold has its own price. Now, could there be 2 trucks that are $40,000 each? Yes. But are they 2 totally different trucks? Right. No one truck is going to have 2 price tags on it. Does that make sense? Every truck has just the one price. You with me on that? You don't walk up to a truck and say, well, now which price? And I'm going to pay the cheaper price if there's more than one price on it. Every real number is the square of that number. We're not going to go that deep with it. That's more of real analysis. I just left that in there because I liked it. Okay, domain is your input. The range is your output. If you're talking about sets, then we use the word element instead of numbers. The concept behind a function is that for every input, there is exactly one output. And that is why it says right here, there is exactly exactly one, it says range, this is the output. For every input, there is exactly the one output, which makes it a function. And that's so that you can graph it and you can evaluate it and you can apply it to real world problems. If there was a chance that there were multiple outputs, then that would be ambiguous and you would be confused. You know, it'd be like, go back to the fitness class. If the fitness class said, how many classes do you want to attend? And you said 10, and they said, well, that'll be either $45 or $27. That wouldn't make sense, would it? Like, well, how can it be two totally different prices if I just told you I'm coming 10 times? So that's where the importance of a function, when it has exactly one output, it's so that you basically can get your answer. And there's only one answer. Okay? More real world examples. If you look at the first one, it is just numbers. So like -6, if it was plugged into an equation, it's saying that the output is what? 36. If I plugged in +6, the output is 36. -3, the output's 9. +3, the output's 9. If I plug 0 in, the output is 0. Is that a function? Yes, because every single input went to only one output. Can outputs repeat? Yes. But coming from the input, it cannot repeat. You notice here there's only one. You see that? So it's always the x coordinates that you're checking. It's the input coordinates you're checking to make sure that it only got assigned to one thing. I think cookies are back. It's unlocked. Does anyone else want cookies that didn't get a chance? Oh. You already ate them? I'm going to make a note. There is only, there's only one y value assigned to each x value. There's only one y value assigned to each x value. Another way to think of it is there's only one assignment coming out of each x value. That's another way to think of it. Y values can repeat, x values cannot. So if you want to make that note, it's okay for y values to repeat. It is not okay for x values to repeat. The second real-world example is talking about when presidents appoint Supreme Court justices. So if you look at it, so George H.W. Bush appointed Clarence Thomas, Bill Clinton appointed Stephen Breyer and Ruth Ginsburg, George W. Bush Jr. appointed Samuel Alito Jr., John Roberts Jr., and then Barack Obama appointed Alina Kagan and Sonia Sotomayor. So is that an example of a function? And the answer is no, because you have Bill, George, and Barack, who all appointed multiple Supreme Court justices, which means that this x value has been repeated. And the way to see that is multiple arrows are coming out of this x value. Okay, so this is not a function. This is no. Some presidents have multiple, you can write Supreme Court justices here, or you could just write arrows. I'm just going to write the arrows because that was them assigning it. And that's a shorter shorter word. So this is the problem right here. This is a problem, this is a problem, and this is a problem. So the next slide is 4 more examples, and it's asking you to determine yes or no. These are a little challenging to wrap your mind around. I'm not going to lie, a lot of people, they can't stand these because they just want it's like, this is when they just want numbers and letters. They don't want a real world situation. What you need to ask yourself is the input, the X, is it getting repeated? Because if it's getting repeated, that's a problem. So the first one, years in which a presidential election occurs. Okay, so you need to think of when presidential elections occur. They occur every 4 years, and they line up with the Olympics, right? The main Olympics, not the winter. So help me out. Let's see, it's 2022. It was 2020, right? Was the last election year. So 2020, 4 years prior, 2016, 2012, so on. So think of the list of years. The correspondence, so the arrow is saying, in that year, who won the presidential election? And then you think of the list of presidents. I'm not going to write them all. Would that be a function? I see a yes. I hear a yes. Do you feel confident? Good, because it's yes. In a single year, don't get nitpicky. Don't start going down the political rabbit hole because I can't handle it. If you, in a single year, were there 2 presidents? No. Every year there's 1. So each year that there's an election, it gets assigned to a single president. Does that make sense? So this would be an example of a function. So you just say yes over here. None of the years get repeated. You know, we didn't list 2020 and then say, oh, but 2020 again, later in that year, we picked another president. It didn't work that way. So that's why it is a function. Take a second, try the next one. VIN number on a vehicle, if you don't know that, that stands for vehicle identification number. It is like a social security number for your car. There's your hint. What do you think of? Yes. All cars produced in 2016. Okay, just imagine a big old lot of cars. Every one of them has a VIN number. So then think of having a report with all the VIN numbers on it. Is there a single car on that lot that is going to report out with multiple VIN numbers? No. So this is a function. This is a function because each card has only one assigned VIN number. No car has multiple VIN numbers, if you need to make that note. All right, the set of all I'm going to help you with this one. I'm not a golf fan, but I've done this problem in the past, and people are like, I have no clue. The set of all professional golfers who won a PGA tournament in 2014. So think about, there's a tournament going on. It doesn't matter if you know golf or not. There's a tournament going on, right, in the year 2014. The PGA tournament. List all the winners. It says the set of all golf professionals who won a PGA tournament. Are there multiple tournaments in a year? PGA tournaments? I think there's
there's multiple.
Yes, there's multiple. Okay, so if there's multiple tournaments in the year, there could be a person who wins multiple. Tiger Woods, perfect example, right? Before he before he kind of left the spotlight. He was winning like every tournament that he entered. So because his name is getting assigned to the winner, like the set of all the tournaments, like let's say he had the Windstone tournament, I'm just making this up, and he won it. Then let's say he went to Augusta, and he won that tournament. So he's got multiple arrows coming out of his name to the names of the tournaments. So this is not a function. And you can make a note, one golfer could win all tournaments. There's your perfect counterexample. Let me do the last one before the bell rings. The set of all PGA tournaments in 2014. So this was the golfers. Now this is the tournaments, right? So this would be like Windstone, Augusta, Dalton Golf and Country Club. I'm trying to think the farm. And then the winner of the tournament. This would be the names who won it. Imagine arrows. Yes or no? Yes, because there's only going to be one arrow coming from the tournament, and that's going to go to the winner.